Okay, as promised, it's time to come to a really important result. Now, this is basically fundamental to lots of higher trigonometry. It's called the compound angle formula, the sum angle formula, sometimes a double angle formula. So if I have cos of alpha plus beta, there's actually an expression for this in terms of cos of alpha, cos of beta, sine of alpha, and sine of beta. So I'm just going to write down what it is. And again, it's an identity. So there's a cos of alpha, cos of beta, minus sine of alpha, sine of beta. Now, why on earth would this be true? Well, let's get some intuition behind it first of all. How about we do a couple of examples in order to get our heads around what this really means, right? Let's plug in some numbers to check, is this really true? So what if alpha equals beta equals 30 degrees, right? But let's write that as pi over 6 now that we've moved to radians. Now remember, in a previous video I showed you the pattern for remembering all of these things, all of the values that cos and sine take at these angles. Now if they're both pi over 6, then adding pi over 6 to pi over 6 will give pi over 3. Now we know what cos of pi over 3 is. Well, I'll come to that in a minute. Currently I'm just gonna shove all this into the identity. Here, this is what I'm doing to check it's true, right? So cos of alpha, that's now cos of pi over 6. Cos of pi over 6 again. Yeah, and then minus sine of pi over 6 minus sine of pi over 6. I'll just write it as sine squared pi over 6. I could write the first one as squared as well. Now what is cos of pi over 6? Well, that's cos of 30 degrees, and from our table or from memory we know that this is root 3 over 2. Of course I'm going to square that. Sine of pi over 6 is now a half, but I'm going to square that. And over on the left here, cos of pi over 3 or cos of 60 degrees is a half. So is this indeed true? Well, let's check. Root 3 over 2. Well, this squared over this is going to be 3/4, and this is going to be minus a quarter, which is indeed a half, so it works out perfectly well. Okay, so there's a bit of intuition. You can play around with it and work out some other angles with it, but I'm going to use it more in later videos. Right now I want to show you a really elegant proof of this, but before I do that, let me write down another. I think I'll save the proof to the next video just so it can have its own video. But the next identity that we'll have is a similar one for sine, right? So similarly, let's go over here. So I'll write down one for sine as well. So we have another one for sine of a plus b, alpha plus beta here. It's going to be sine of alpha cos of beta plus sine of beta cos of alpha. Okay, so let's again check that this works. So let's set alpha equal to pi over 6, and this time set beta equal to pi over 3. Okay, now this is 30 degrees and 60 degrees, so that should add to give 90 degrees or pi over 2. So the left hand side here, if I sub in these values, this is going to be sine of pi over 2. Okay, and what's that? That's just going to be 1, right? So let's look at the right hand side. So the right hand side is going to be, so alpha is pi over 6, so this is going to look like sine pi over 6 cos of pi over 3 plus sine pi over 3 cos of pi over 6. And again, these are all values that we actually need to know for the exam, right? This is on the specification that we need to just be able to recall each of these values. So I'm just going to write them out. Note that's also a half. And these two are both root 3 over 2. Okay. So there's going to be a quarter plus 3/4, so it's 1 as required. So that's all good. So this identity holds in this case. It'll hold for every single value of alpha and beta, and so will the one for cos. And the reason is, and again, I forgot my equivalent sign today because this is an identity. So what is the reason? Why would this be true? It seems kind of strange that you can write, you know, it's quite unintuitive, quite weird to play with at first, especially when I see all this algebra. You would usually use these in a simpler form, right? If you take alpha equal to beta here, if you take, you know, let's set them both to be theta, for example, right? So then we have sine of 2 theta, which is going to be, let's see, sine of theta, cos of theta, and so on. So you see it's actually just twice sine of theta, cos theta. There we go. So that would be the double angle identity in this case. So this is a more common form it's seen in. And then we would also have the cos one. We can go back, look at that formula, and sub in this. And this is what we're going to get out. Okay, so these are the more commonly seen versions of these combined angle formula. But of course, this still doesn't actually answer the question, why is this true? Yeah, and why is the cos one true as well? Well, I will explain that in the next video.